Okay, I'm going to produce a real quick video on how to turn your data into the graphs for the Excel lab write-up. So this is a copy of my data. Just a word of warning about plagiarism. If your data comes out looking exactly like my data, then that's plagiarism and that's not okay. So this, I've put both my positive data and my negative data here on the same chart. As you can see here, this is my positive from the positive wing, and this is my negative from the negative wing. Here's my positive position here, or my negative position there, and positive position there, and then all of the other data points. Okay, so what I'm going to do now is show you the graphs and make sure that you have those set up correctly. So here is a picture of what the position versus time graph should look like. I'll move this data out of the way. So you can see here on the x-axis that you have the change in time, and on the y-axis you have the change in position. It should be labeled exactly like you see mine. It should be, these numbers should be exactly like you see mine, starting at negative 70, negative 60, 50, 40, 30, 20, 10, 0, 10, 20, 30, 40, 50, 60, 70, and finish with 80. Should have a title, position versus time, and then you should have delta t equals change in time, and parentheses your units, and so it should look exactly like that. Now I'll bring my data back on screen here. It'll cover the side of the graph here, but that's okay. You can see that. So what we're going to do here is we're just going to plot, and I'm only going to do the positive, but we are going to plot the delta y, or delta x, which is the change in position. So this data right here versus the change in time, this data right here. Okay, so those are the two data that we're going to plot on this particular position versus time graph. And I'm only going to do the positive. You'll do this for the positive and for the negative data. So you'll have one line that goes positive, like the one I'm about to draw, and one line that goes negative. So we'll just start out plotting the position. So we start out with 10 and 0.1518. So we go to 10 and we go to, there's 0.1, there's 0.15 right there in the middle between 0.1 and 0.2. And we're going to put a dot right there where they intersect. Okay, then we're going to go over, we'll do the next one. It'll be 20, and it'll be 0.264. So 0.25 is right there, 0.26 will be somewhere right there. We go up to 20, and again we're going to put a dot right there at that point. And then we're going to just move on. We're going to do 30. And 0.362. So we're going to go over here 0.36, go up to 30, and put a dot right about there. And we would continue that process, and then when we're done, we would simply connect all the dots, very simply, with just kind of a straight line. So we're just going to connect the dots real quick here. Change the color for this one to red. And we would have more data points, of course, to connect. And that's how you would do the position versus time graph. Okay, next would be the velocity versus time graph. So we're going to go over here. Again, I've got my data over here. I'll move this out of the way so you can note how this graph is laid out. Change in velocity versus change in time is the title. On the y-axis, you have delta v equals change in velocity and the units, which is centimeters over seconds. And then you have the numbers, which starts out at negative 120, then it goes 15 per box, so 105, negative 105, 90, 70, and so forth, all the way up to 105. And the change in time, same exact change in time that we plotted on the last one, so the layout is exactly the same. Every 4 boxes, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Okay, and then we do the exact same thing, only this time we use the change in velocity data, which is right here where it says delta v and the delta t. So we're going to use this one and this one. We're going to use these two. Okay, so now that I got that all highlighted for everybody, what we're going to do is, so then we just go and repeat the same process that we just did, only with these two. So we'll start out with the first data point, which is looks like 23.9. We don't have that kind of resolution, so we'll just go up to somewhere between 20, 15 and 30. In the middle would be 22.5, so that's somewhere in that ballpark. And then we'll go over to the time, and that's 1.5, so it's going to be halfway between 0.1 and 0.2, so 0.15 would be right there. Okay, then we'll go to the next one, which is 42 and 0.26. So 42, there's 45, so it's just below that. 0.26 is just past 0.25, so we'll put it right there. And then we go to the third one, and that is 57 and 0.36, so it's just below 60, 0.35, a little past 0.36 or 0.35, so we would put it right there. And then again, you would finish off with the rest of the data points, and you would connect these data points to each other. And that's how you would do your velocity versus time graph. Again, you're going to have a positive graph and you're going to have a negative one. Make sure you color code these with different colors. So you'll have some points down here on your negative graphs that go that way. And likewise on this one, you'll have a positive position versus time graph and a negative position versus time graph, like that. Alright, so if you have any questions, please get in to see me in tutorials and get this assignment turned in as quickly as possible.